Now let's do some problems together. In these problems, we have variables on both sides, so we'll just have to work it out. All right, number one, 6x plus 3 equals 8x minus 21. The goal is to get all the x's on one side and all the numbers, constants, on the other. I like to kind of see what I'm working with before I move anything. Remember, to move something, you have to use inverse operations. So what I can do is I can undo the positive 8x by subtracting it. But look here, I've only got 6x's over here, so if I subtract 8x, I'm going to end up with negative x's over here, which is fine. It'll work out that way, but I kind of like to make sure all my numbers stay positive. So I'm actually going to undo the 6x first and get all my x's on the right. It's okay, you can do it any way you wish. There's many ways to do this problem. This is just the way I like to do it. So I'm going to take away 6x from both sides, rewrite what I didn't use. 8x take away 6x, that's going to be 2x's. And now I'm going to undo this minus 21 by adding 21 to both sides. See how all my numbers stay positive? And 2x equals 24. And now I just divide both sides by 2. X equals 12. Final answer. I'm not going to check this step, but you can always check your work. All right, here we go, number 2. I've got some decimals here in my problem, but if I've got a calculator handy, I don't have to always clear my decimals. So this way, in this problem, I'm not going to clear any decimals. I'm just going to work it out. I'm going to undo this positive 1.5h and kind of move it over to the other side so that all my numbers with my variables are on the same side. Rewrite what I didn't use. So 3.5 take away 1.5 is just 2. So I've got 40 equals 2h, and just divide by both sides by 2. H equals 20. Very easy. All right, over here, I've got negative 36 plus 2w equals negative 8w plus w. I need to go ahead and combine like terms on the right side of my problem first. Negative 8w plus 1w is negative 7w. Because remember, if a variable does not have a number in front of it, it's understood that there's a 1 there. So rewrite what I didn't use. Now, my only choice in this problem is to undo the positive 2w and move it over here. Because if I move the negative 7w's over there, then I wouldn't have anything left over on the right side of my equation. So I need to have something on both sides. So in this case, my only option is to move the 2w by subtracting it. I'm left with negative 36 on the left side and actually negative 9w over here on the right. Because 7w take away 2w is actually negative 9w's. Divide by negative 9. Negative divided by a negative is a positive. So w equals 4 in this case. All right, last one. You want to give it a try on your paper? The first step is to distribute. Make sure you distribute the 4 also to the 5. Now you have to undo the 4x. Divide by 2. X equals 10. Did you get that? All right. Now we've got some more complicated examples that I went ahead and worked out for you, but you can always just copy this down and go through it with me right now. So you've got some massive problems with fractions. The best way to handle this is to clear all the fractions. So I've got 2x over 5 minus 3/5 equals negative 1/5 minus x over 5. If you look and see, all your denominators are 5. So the best thing to do would be multiply this entire problem by 5, and it actually clears out every fraction. And you're left with 2x minus 3 equals negative 1 minus x. You're left with all the numerators. And it just so happened to work out that way because all the denominators were the same number. So we got lucky in that one. Now we just go through and solve just like we did the problems on the last page. I am actually going to subtract, I'm going to add x to both sides to get rid of it here. And that leaves me with 3x plus 3 equals negative 1. And then I'm going to undo the minus 3. And that gives me 3x equals 2. And I'm just going to divide by 3. And my answer is actually a fraction. And that's okay. X equals 2/3. As long as I check it to make sure I can check it using my calculator, plug it in, and it will work out. So it's okay to have some answers as a decimal or a fraction. Here we go. Number 2, 3x over 5 plus 1/15 equals 4 plus 2x over 3. And I look at my denominators. I have a denominator of 5, 15, 1, and 3. The common denominator here is 15, so I'm actually going to multiply this entire problem by 15 to clear all the fractions out of the way. This is how you do it. 5 goes into 15 3 times. 3 times 3x is 9x. 15 goes into 15 once. 1 times 1 is 1. 4 times 15 is 60. 3 goes into 15 5 times. 5 times 2x is 10x. Then you can go ahead and solve your problem. So I'm actually going to subtract 9x from both sides and simultaneously subtract 60 from both sides. It's okay, I can do that because the x's are affecting the x's and the constants are affecting the constants, and they're not really crossing paths. So once I do that, I get my final answer, x equals negative 59. Sometimes when you try to solve an equation, your variable cancels out completely. If what is left is a true statement, then your answer is identity. Identity means all real numbers are solutions. So let's take a look at an example. 5x plus 6 equals 2x plus 6 plus 3x. So let's go ahead and combine like terms. 2x plus 3x is 5x. And then I just brought down what I didn't use. Let's go ahead and undo the 5x so I can get both of my variables on the same side. And when I do that, my 5x cancels out on both sides. And what's remaining is 6 equals 6. And that's a true statement, therefore it's identity. Sometimes when you try to solve an equation, your variables cancel out completely. If what is left is a false statement, then your answer is no solution. This means that no value of your variable will work as a solution. So if I've got 4x minus 10 plus 2x equals 6x minus 3, I combine like terms first, and I get 6x minus 10 equals 6x minus 3. I want to get all my variables on the same side, so I undo the 6x, and that actually cancels out on both sides. I bring down what I didn't use, bring down the minus 10 equals negative 3. And that is a false statement. That does not work. Therefore, I have no solution here. Why don't you try these two problems? Press pause on your video, try these on your paper, and when you're ready, push play and I'll walk you through it. In these two examples, I have to use the distributive property. 2 times x is 2x. 2 times positive 3 is positive 6. Bring down the rest. If you notice, at this point, you've got the exact same two terms on both sides. So you're pretty good at assuming this is going to be identity. So I'm going to subtract the 2x from both sides. And I get 6 equals 6. So I've got identity. Okay? Number 2, again, distribute. 3 times x is 3x. 3 times 4 is 12. Bring down the other part of your equation. and then undo the 3x from both sides, and that ends up wiping out all your variables, and you're left with positive 12 equals 4, which is a false statement, so this is no solution. This was a lot of information. I hope you had a chance to soak it all in. Good luck.